Hi guys, I am Vignesh Ganesan from Kalir.in e-learning platform. Now we are going to know how to model this exact solid body in a two different ways to design and Solidworks. Select a front plane, create new sketch, draw a vertical midpoint line from this origin point. Once we draw the line profile, next initiate it with the smart dimensions value of 100 mm to fix this two endpoints now. Okay, now using a 3-point arc, start point, end point, and center point. Now select this center point as well as this vertical line to fix it under coincide constraints. Then change this line profile into a construction line. Now form a revolved surface body. Exit the sketch, go to the surface, choose a revolved surface. Under this vertical reference line, we create a revolved surface body. Okay, what we are going to do is choose the front plane again, create new sketch, draw a vertical line by closing two opposite endpoints now. First one, second one. Either you can from the reference one at the top of its portions or you can close the two opposite points now. Once the enough points is closed, then exit the sketch, choose the front plane again, draw a horizontal line at the bottom of its positions. Once the line profile is drawn, then fix this with this offset value of 15 mm and the total dimensions for this line profile is 60 mm. So mention the horizontal line, that is an offset distance is 15 mm now because the diameter value is 30. Then the total line profile distance is 30 mm. Sorry, 60 mm. Exit the sketch, choose a swept surface. This is a first reference, that is the sketch profile is a horizontal line, then the path curve is this vertical line. Choose an options, follow path, specify twist value, under revolution type, then initiate the number of the revolution. But look at it, here we cannot able to modify the pitch value. Also, it is easily created based on the number of the revolution. That is a 10 different revolutions here. Okay. Once you initiate the revolution, the starting angle as well as an ending angle, it is automatically created. We not modify any of this exact portions. You just created based on the assumptions of this process. Now we are going to create a curves. Using a normal curve, we cannot able to accomplish these portions. What we are going to do right now and how we can handle this to create a curve in these sections. Choose a 3D curve. Under that, I am going to prefer an intersection curves on this area. So choose an intersection curve on the command manager based on the intersection of both the spherical body as well as this spiral body. The new 3D sketch is created. Just hide the overall revolved surface as well as this surface body. Now choose a swept boss. Under circular profile type, selecting this path curve, the solid body is created with the diameter value of 10 mm. But I am going to change the value under 5 mm. Okay, just change the dimensions now of 5 mm. Okay, as the new solid body is created. This is the simplest way, but not precise. Look at it. We automatically create it based on the assumptions of the revolution types. Let's take a look on the second method. Select a front plane, create a new sketch, draw a vertical line, not a midpoint line, just a vertical line. Then offsetting the values under from the origin point, it is 5 mm. Otherwise, the rest of the dimensions is same. The 100 mm of value, vertical dimensions. Then draw a 3-point arc profile, start point, end point, and center point. The center point must be coincident to the vertical line. Once this profile is fixed, then form a revolved surface, same as like how we developed from this existing one. So choose this vertical reference line and create a revolved surface body. What we are going to do is create a number of the planes at this 10 different instance. So choosing an offset value of 10 mm and increasing the number of the instance into 9 because we already have the default top plane. So total number is 10 different planes in this exact spherical body. Next, what we are going to do is show the revolved sketches and choose this each of every individual plane, create a sketch, draw a center point circular profile. Now under point, specify this point. Now choose this point, then coincide it using a pairs options to mate with this opposite 3-point arc profile. Again, selecting this second curve, second plane, draw a center point circle, then initiating a points from the point coincided using a pairs options, it must be coincided to this open arc profile. Choose an each of its every individual plane, Draw a rough center point circle. Then coincided on this left area. Now choose this point again, specified on this location. Then using a coincide to mate it with this opposite one. Okay. Likewise, we are going to select each of its every individual plane to create a number of these profiles. Without giving a dimensions, we fix this profile based on the PS options. That is what the exact thing we need to done that. Once the number of the profiles is created, now look at it. This is the 4 different profiles. Once the number of the profiles is created on all different area, once the number of this circular profile is created, using that we can able to create a path curve. So hide the overall planes. That is a 10 different planes from the new one as well as the top plane also. Hide the number of the planes here. Measure the circular profile value. So choose a measure and selecting the circular profile. What is the dimensions for the circular area? It is 71.4 mm. Copy the value. Go to curves, helix and spiral curve. Already we have a constant pitches. So choose a variable pitch now. After that, initiating the distance. What is the values in this current portions? It is 71.4 mm. Then the revolution is 1 revolution. Now change the height type is 10 mm because that plane position on the offsetting distance of 10 mm. Exit it. Again, measure the another circular profile. Copy the value. Go to this helix and spiral. From the specifications tree, edit the features. Double clicking on this another portions. Paste the values. The revolution number is increased by 2. Then the values is added with another 10 mm. Look at it here. We get the continuous curve. Also, we can able to adjust the pitch dimensions. Then we can able to adjust the revolutions also. Measure each of its every individual circular profile first. Copy that and paste it into the diameter type, increasing the revolutions into 3 numbers. It is adding the numbers one by one up to this last profiles. The pitch value is added. Also, the revolution type is increased. Once you measure all these values, paste it, increasing the revolutions, then adding the height type. This is how the continuous curve is created on all part of the way. It is easy to make that. It takes a time only, but you can able to control every curve. That is what the exact difference of it. Once all different curves is created based on copying and pasting of the diameter value, then increasing the revolutions type, also increasing the height value by adding of 10 mm in each type. Okay, start curve as well as a continuous curve is positioned on the one particular point itself. It is here the start angle is 270 degree, end angle is also a same kind of a degree value. Hide the overall 2D sketch, both the top one as well as the bottom one. That's it. Here we got an ellipse curve. Go to swept pose and form a solid body. So choose the features on the top of its command manager. Select a swept pose. Under circular type, change the value of 5 mm. Then selecting this spline profile. Here we created this solid features. Look at it. I just changed the method of creating each and every profile under variable pitch, but my solid body is created on the precise way. Let's compare a two different solid body into these portions. This is the first one, and this is the second one. Open the previous body, selecting it and open this. It is a left one, it is a right one. Left one specifications tree is less. Right one specifications tree is more by creating a number of the planes as well as using a number of the sketch. But if you take a look on this left one, once we created a spherical body and form a line using a swept surface, it is not a precise one, but it is an easy method to define any of the spring surface body. It is an easy method under a specified twist value type. But you cannot able to adjust the pitch distance, also the revolution type. One revolution takes one kind of a length. But if you take a look on this right side, it is a precise one, but takes much time compared to our previous one. You can able to control the pitch distance. You can able to control the arc angle, okay, by initiating the variable pitch diameter revolution type pitch distance in one by one manner, but it takes time. That is what the difference of creating any kind of a solid body. Here, I'm giving the questions now. What type you choose? Which type is this eligible for to get a precise model with a less time? That is what the question was. Think about and form a new body based on your preference also. Okay. If you want to learn a full course with the detailing content and example, choose a SolidWorks professional course at www.kalere.in to learn with example.